Hi, and we are doing Module 4 exam, the written exam, Chapter 6, Fractions and Rational Numbers, right? Exciting, exciting. Okay, so the first thing we're going to look at is, there we go, taking shapes, larger shapes, smaller shapes, and seeing what the fraction is that represents the relationship between the two different shapes. First, we have the hexagon. And with the hexagon, we're going to take the trapezoid, and we notice that we can fit 1, 2 trapezoids inside the hexagon. So since we divided the hexagon into 2 equal parts, the denominator is going to be 2 in this case. For every 1, the trapezoid, the number representing the trapezoid is on top. For 1 trapezoid, we have 2. The trapezoid takes up 1/2 of the hexagon. So for every 1 hexagon, we need 2 trapezoids to equal that 1 hexagon. Okay, finally got it out. Here we go. Next, we have the triangle. So we have 1, 2, 3, 4, 5, 6 triangles. So our triangle is 1/6 of the hexagon. For the rhombus, we have 1, 2, and we see 2.5, and there's another half, so that's 3. So it would take 3 rhombi to completely fill a hexagon. So our fraction there for a rhombus is 1/3. So a rhombus is 1/3 of a hexagon. And we're going to do the same thing here. But let's see, 1, 2, 3 trapezoids. So a triangle is 1/3 of a trapezoid. For the hexagon, we did not divide the hexagon, but the trapezoid only takes up half. So on this fraction, we put 2 at the top, meaning you need 2 trapezoids to equal 1 hexagon. So you need 2 whole trapezoids. So for the rhombus, we see that it takes 1.5 rhombi to equal 1 trapezoid. So 1 rhombus is 2/3 of the trapezoid. And we can see here with the triangles, it took 6 triangles to equal 1 hexagon. For the trapezoid, as seen earlier, we need 3 triangles to equal a trapezoid and 2 triangles to equal 1 rhombus. And we're gonna, this is a repeat of the fractions we've already done. And here we go to problem number 2. So problem number 2 is a length of rope was purchased at a hardware store, and we need to figure out how much that original length of rope is based on information in the problem. So here, a man bought a length of rope at the hardware store. He used 1/3 of the rope to make a bow painter for his canoe, and then used 1/4 of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope. What was the length of rope he originally purchased? Well, first we need to figure out what information was given in the problem. So the first important part of information was 1/3 of that original length was used as for the bow painter. Then 1/4 of what was left was used to tie a carpet, and then there was 36 feet remaining after that. So here we go. So we took our original length of rope. So this dark black line represents our original purchase. And then we divided that into 3 equal sections. So there's our 1/3, and we're going to label that for the bow painter. Next, we take what is left. So we're eliminating this section, and we're going to take this section here, and we're going to take 1/4. So we divide it into 1, 2, 3, 4 sections. 1/4 of that was used to tie carpet. Then we know what was left was 36 feet. Well, what was the original length that was purchased? Well, we know we can take this 36 feet, and by looking at it, that is half of the length of rope originally purchased. So we multiply 36 times 2 to get 72 feet. Next, we're going to represent each fraction using a fraction strip and number line diagram. So our original fraction first is 1/3 plus 1/2. The first thing you need to make sure you do, or have your students do, is look at the denominators. If the denominators are not the same, you must convert them. You must get a common denominator. In this case, the lowest common denominator is 6. Worst come to worst, multiply the 2 denominators together, and that will give you a common denominator, and then just make sure you make your fraction equivalent with the new denominator. So here we go. 1/3 plus 1/2 is equal to 2/6 plus 3/6. And first we're going to look at the number line. So we start at 0, and now because our new denominator is 6, that tells us that this number line is divided into 6 equal portions. So 2/6, so that means 2 of these sections of 6, we're going to jump with an arrow. 1, 2, our arrow lands there on 2/6. Then it adds 3/6. So that means our next arrow needs to go forward 3 spaces. So here we go. 1, 2, 3. So, ooh, I just jumped ahead. So now we know that 2/6 plus 3/6 is 1, 2, 3, 4, 5, 6. Then we can look at our fraction bar. And then the top one, we're going to take what was originally given, that 1/3, and we're going to take a length of bar and divide it into 3 equal places, equal parts, because our denominator is 3. So really hone in on that. Anytime you have something and it's divided with a fraction, the denominator tells us how many parts it's divided into. The numerator tells us how much of it is shaded or how much of it is missing, how much we've used. So in this instance, 1 of the 3 sections is shaded in. Next, we have 1/2. So we're going to take that same length for a fraction bar, and then instead of dividing it into 3, we're going to divide it into 2 because that is our denominator. And once again, 1 is our numerator. So we have 1 section shaded in. When you're adding fraction bars, for it to work like this, you're going to take the first fraction bar and lay it down. And then underneath it, you're going to take the second fraction bar, but you're going to put the end of the second fraction bar equal to, just underneath, but in line with the end, the back end of that first shaded in area. So it would be, if you laid them on top of each other, they would be continuous, but we're going to put it right underneath so you can tell the difference. And then beneath that, so if you remember from when we originally discussed this problem, our common denominator was 6. So our final answer has to be a fraction bar divided into 6 equal places. So we took the same length that we used for the first two, because remember, each bar has to be exactly the same length. It's just how much we're dividing it by that changes. And in this case, you had 6 equal places, and we highlighted, when you divided it by 6, you will notice that 5 of those places should be shaded in according to the length from your first two fractions. Next, we're doing the same type of information. We have a fraction bar that was half of it shaded in because our denominator is 2. We know it's divided into 2 parts, so the numerator is 1. The next fraction bar, our numerator is 3, but our denominator is 4, so that tells us we need 4 equal parts. 3 of them are shaded. In this instance, we know that our common denominator is 4, so our fraction bar is divided into 4. But when we added them together, if we'd have just put 1 fraction bar, well, that wasn't our answer. We needed more. So we added another fraction bar, but once again, it still has to be 4 equal parts. So here we notice that it is 5/4, which is, if you notice, you can see real easy that it's 1 whole plus 1/4. And then we look at our number line, and we do the same as we did earlier. We start at 0, and we go, well, we looked at our denominators. We got our common denominators and worked out the equivalent fractions. We went from 0, and we jumped 2 spots. And then the next one says we need to go 3/4. So that's going 3 portions forward. And then that gives us 1 1/4 or 5/4. For subtracting, it's similar, and you're going to get this. So once again, we got to make sure we have that common denominator and adjust your fractions accordingly. We want equivalence. Remember, 3/4 is equivalent to 9/12. There's an infinite number of equivalent fractions. Okay, so the first section, we're going to use the original problem, and that's telling us we need a fraction bar of 4 with 3 shaded in. The difference in subtraction, instead of laying the second problem, the front end of the fraction bar, even with the back end of the first fraction bar, we're kind of doing it opposite. So what's going to happen is you're going to take the second fraction bar and move it over to where, instead of it lining up the top one and the bottom one, you're going to move it to where the back end of that second fraction bar is in line with the, not the back end of the fraction bar, the back end of the shaded area of the second bar will be equal to the back end of the shaded area of the top bar. And that will give us our answer. For the number line, we're going to start at 0 again, and it tells us we're going forward 9/12. So our line is divided into 12. We're going to go forward 9 spaces. Well, then we're subtracting. So when we get there, we're going to turn around and go backwards 4 places for 4/12, and that gives us 5/12. And we're going to do the same on this fraction. Okay, so now we're looking at, we're going to represent each of the multiplication fractions. In this case, and we're going to do it with fraction circles and a number line diagram. And here, each of the circles. So we know we're multiplying 3 times 1/5. So we need 3 of whatever 1/5 is. So 1, 2, 3. And you will see each circle is divided into 5 equal places, as much as I can get it there. And we shaded in one area. So you will see 3 represented of 1/5. 3 times 1/5 is 3/5. And when we look at a number line, remember our number line, once again, I'm drilling that into your brain, that it's so important that the denominator is representing the number of equal parts that we've divided something. So we divided that number line by 5. The numerator tells us how many places forward we go. And that's 1/5. So this 3 is going to show us how many times our arrow is going to jump 1/5. And then we do that with 2/4 and 5/8. So see here, you start getting fancy. It gets exciting, and you can do this. Now, when we look at negative, -5, do not get overwhelmed because there's a negative number. Same thing, we're just going the opposite direction. Just do not forget to keep your negative. So on this number line, you will see instead of going to the right, we're going to the left. Same problem. You just kind of reverse it a little bit. Okay, so this is the thing that initially even overwhelmed me, but here we go. So what is a tangram? You know, we're taking this square and it's divided into all these pieces, and oh, I didn't move my F over, but this brown area is the F. So what exactly are we doing, and how in the world are we going to figure it out? Well, first off, this is a Chinese geometric puzzle, and it consists of a square cut into 7 pieces that can be arranged to make various shapes. This is fun, and actually your kids have probably done this. If you're a student, you've done this, beginning even in kindergarten. We make lots of shapes and characters using our different shapes. So now we're going to figure out the area. So first off, we start off with this square, and this square is divided into 4 equal parts. Therefore, we know since there are 4 sections or 4 equal parts, then it is 1/4. 4 is going to be the denominator, so both section A and section B are equal to 1/4 square units. Simple, right? We got this. Okay, now let's divide up one of those sections. So how much can fit into one of those 1/4? Well, we can see this triangle fits 1, 2, 3, 4. So that section of 1/4 can be divided into 4 more spots. So there we have to multiply 1/4 by 1/4. So, and I know as I'm reading this, each 1/4 section can be divided into by 1/4. But to get how much area our smaller triangle is, we have to multiply 1/4 times 1/4, and that's going to give us 1/16. So areas A and B are 1/4 square units. We figured that out originally. So what is C? Well, we just figured out that this green triangle is 1/16 square unit. So then we have D. Well, how do we figure out D? Well, what we can do is take that smaller triangle and fit it in there, and we notice 2 triangles fit into D. So we know that D is 1/8 square unit because 1/16 plus 1/16 is 2/16. And then 2 goes into 2 one time, but 2 goes into 16 8 times. So we reduce that fraction to 1/8. Next, we're looking at E. And once again, E, we already know that triangle is 1/16. Then we're going to go to F. Now, F, if you look, the shape of F is a rhombus. But 2 of these triangles will, and I guess it should be a square, but it's kind of awkward. Anyway, 2 triangles will fit into F. So that tells us, once again, it's that 2/16, which can be reduced. So F is 1/8 square units. G, oh my goodness, what's G? Well, if you notice, I made G kind of transparent so that you can see, you know, originally we had this line going from A through A and B, dividing the center of our square. So G is actually 2 smaller triangles. So once again, we have G is equal to 2/16, which we can reduce to 1/8. See? Piece of cake. Okay, so next we have a recipe, and I am so excited. Okay, I love recipes. I love cooking. So we're given a brownie recipe, and it's going to make 16 brownies or yield 16 brownies, which is just a fancy way of saying make. So in case you see it, there you go. Yield means that's what you're going to produce. So how much of each ingredient are we going to need to make 12 brownies? So where do we even begin? Oh, see, he's depressed because we all felt overwhelmed thinking, what? How do I make a recipe for 12 brownies when I was given a recipe for 16? Just so you know, no, you can't just eat the 4. That's not how we solve this problem. That would have been my kid's answer. Okay, so what we must first determine is how much of the original recipe we will need. To do that, we must divide the yield of the second batch by the yield of the first batch. So the first batch, the yield goes on top. So that's 12. The second batch goes on bottom. So you know a fraction is just division, right? So here we go. So that is 12 over 16 is equal to 3/4. Piece of cake. We can do 3/4. That makes sense. Then you're going to multiply the measurement of each ingredient by 3/4. So we take our butter, which started out with 1/3 cup of butter, and we have to multiply that by 3/4, and that equals to 3/12, which we can reduce down to 1/4 cup of butter. And then we have unsweetened chocolate, 3 times 3/4, 2 1/4. Sugar is 3/4 times 3/4 is equal to 9/16. And then we go to vanilla, and it's 1 1/2 times 3/4, and it gives us 1 1/8. Eggs, we had 2 eggs times 3/4 is 1 1/2 eggs. Figure that one out. And then we have flour, which we had 2/3 of a cup of flour, and we have to multiply times 3/4, and it's going to give us 1/2. Just in case you're interested, when we reduced our sugar to 9/16, the best way to do that is it comes out to 4.5 ounces, and if you don't want to weigh it, you can do 1/2 cup of sugar plus 1 tablespoon of sugar, and that will give you the right amount. The 1/2 egg, I've not figured that one out. Let me know if you do. Okay. Well, I froze up. camera froze up, huh? Well, I hope you enjoyed this. I will see you Tuesday. Thank you. As soon as I figure out how to stop the video.